So here we discuss about exponents. Exponents. Let me introduce exponents as let us suppose if I have a raised to the power b, where this complete expression is treated as base raised to the power exponent. So if I have something like 2 raised to the power 3, I would be treating 2 as my base, 3 as my what? Exponent or power. So it is a basic convention for the exponents and powers. So let us now illustrate how do we determine the value of exponents. So let us quickly see an illustration for 2 raised to the power 4. Okay, so what does it signify basically? It signifies, you may just remember a general thumb rule like multiply base exponent times. What do I mean by that? Multiply base. So my base is what here? 2. So I will be multiplying 2. How much times? Exponent times. Exponent is my 4. So I will be multiplying 2 4 times. 2 cross 2 cross 2 cross 2. So this is my answer for 2 raised to the power 4. On simplification, I would be getting 4 into 2 into 2. Further simplification, I would be 4 cross 2 is my 8 cross 2, which would again further simplification would give me 16. So 2 raised to the power 4 would give me what? 16 as my answer. So this is how I determine my exponents. Okay, seems clear? Any issues? You may just raise your question if you have. Yeah. So let me give you a couple of questions for solving by yourself and letting me know you are getting the concept or not. Okay. So please determine 3 raised to the power 5 and 4 raised to the power 4. You just try to attempt and let me know what you are getting as your answer. I will be solving here in front of you after a while. I think you must have solved for it. So I have given you the general thumb rule that 3 is my base is my 3, exponent is my 5. So I will be multiplying base exponent times. So 3 cross 3 cross 3 cross 3 cross 3. This 3 cross 3 9, again 9. So 9 into 9 into 3, I would be having 9 cross 9 is my 81. 81 times 3 is my what? 243. I would be getting 243 as the answer. Okay, for 4 cross 4, 4 is power 4, I would be multiplying my base, which is 4 times. So I would be having 4 cross 4 cross 4 cross 4. So on simplification, 4 cross 4 gives me 16. So 16 cross 16 I would be having. 16 cross 16 would give me what? 16 cross 16 is 256. So this is how. Okay, so you are getting the same results. Okay, nice. You are getting ahead. Yeah, that's pretty much good. So this is how we determine basic exponents. Okay. So let us now clearly understand about we can have exponents as negative. Okay. We also have a concept of negative exponents, where we would be also like having the terms 2 raised to the power minus 3. Now what does it signify? See, just the negative sign, what does it signify is, negative sign just signify that whatever is my base is, for here I am having base as 2, whatever my base is, I will be just reciprocating it like it would be 1 by 2 reciprocal of A. Reciprocal of A is 1 by A. 1 by A reciprocal is A only. And similarly, if I have AB, reciprocal of which would give me B by A, and further if I reciprocate, it would give me A by B only. So it is my general thumb rule for a reciprocation, which you might have learned in your earlier classes. So it is a basic concept about reciprocation. The negative side would signify that I have to first reciprocate it, then assign my exponent, which is 3 only. So I would be having 2 raised to the power minus 3 turned towards half raised to power 3. Are you getting it? Yeah. So now what I will do? My base is half. The general thumb rule would also apply here. Multiply base exponent times. Base is my 2, exponent is my 3. So I would be multiplying my base 3 times. My base is half. So half multiplying 3 times would give me what? 1 cross 1, it would be 1 only, and here would be 2 cross 2 itself. So it would yield me 1 upon 8 as my answer. So this is my answer. Clear enough? Okay. So can you solve for 3 raised to the power minus 3? Can you just attempt and let me know what you are getting as an answer? Okay, you are getting 1 upon 27. Let us clearly check. My base is 3 and I have negative, so I would be reciprocating 3, would be getting 1 by 3, exponent would be 3 only. So now applying here laws of exponent, which was A upon B times M, so I would be distributing my exponent to numerator as well as denominator separately. So I would be having things like, 1 raised to the power 3 divided by 3 raised to the power 3. So now applying general thumb rule, we would be multiplying 1 3 times, multiplying 1 3 times, as well as 3 multiplying 3 3 times, which would give me something like this. 1 cross 1 would be always 1 only, 3 cross 3 would be 9, 9 cross 3 is 27. So yeah, you was getting your correct answer. Okay, so let us now quickly jump over a new concept of multiplicative inverse. What is my multiplicative inverse? Let me just illustrate. Let us suppose you have given find multiplicative inverse of 2 raised to the power minus 4. So how would you determine it? You would be determining it as, if you have to find the multiplicative inverse of any number, you just multiply that number with an unknown number. Let us suppose I am treating that unknown number here to be x, and after multiplying that number, you should always get 1 as your answer. So you have to determine value of x, which would be your multiplicative inverse for your given exponent, which is here 2 raised to the power minus 4. So you have been asked for finding multiplicative inverse for an exponent 2 raised to the power minus 4, and if you have solved for x, you will be getting your answer. So let us quickly check it out how would be determining value of x. So see, I have 2 raised to the power minus 4 multiplication with x here. Okay, if I just take x at my RHS side, meaning that if I just divide my equation with x, what would I get? 2 raised to the power minus 4 cross x. I would be dividing my LHS, not 2 bit. I would be dividing my LHS with x, as well as for holding the equation to be true, I would also divide the equation to be at my RHS side. So it would be seeming like this. So here x would cancel with x, okay, and here I would be having 2 raised to the power minus 4 equal to 1 upon x. So I needed the value of x. So what I would do, can you just guess? I'm in need of x only, and here I have 1 upon x. So what operation would I perform for getting my value of x? Can you just guess? Yeah, I would just reciprocate both sides. Reciprocate both sides. So if I just reciprocate, which meaning if I just take my inverse, which is this is, I would be treating it as a number, so I would be reciprocating 2 raised to the power minus 4 equal to I would get x only. Okay, so here what you will apply the identity, if you know the formula, if you know the thumb rule, if you divide a and here you have a and here you have exponents like x and y, it is a rule of exponent. It is a rule of exponent basically. Okay, laws of exponent, which I will be teaching you in a while. It would give me what? If I have something like this, that x minus y, it would give me like this. Okay, if I have same basis at my numerator and denominator. Now observe carefully, how can I write 1 as my 2? For using this property over here, I would be having numerator as 2 as well. So can I write my 1 as 2 raised to the power 0, since I've been using another property of exponent, which states that if an exponent of any number is 0, it should always be 1. So I would be having like this. Now my base becomes same, which is my 2 in this case. So I can apply this formula, this property of exponent directly. So I would be having 2 raised to the power 0 minus of minus 4, which would give me 2 raised to the power plus 4. So basically I would have find out my value of x, which is basically 2 raised to the power 4. So it is my multiplicative inverse of my given question, which was this question. Okay, so you can think that I can just opposite my sign, whatever the sign would be given to me. So from here, what is your observation, that for a direct thumb rule, you would be remembering that multiplicative inverse, if question is given to be like find multiplicative of inverse a raised to the power minus b, multiplicative inverse would be what? A raised to the power b only, and vice versa. Seems clear? You may remember this general thumb rule for further of the questions. So let us now jump over my laws of exponents. Okay, laws of exponents. Do you have any issues up till now? Let me just clearly pop it up if you have any of the issues. I may try my best to address those. Okay, let's see. We have basically 6 laws of exponents. Six laws of exponents. Here the first would be what? You would be remembering all these. Okay, so we have laws of exponents like if I have a raised to the power m times, if I have same base a raised to the power n, then in the multiplication, if my both exponents are in multiplication, and for the exponent my base are in common, that means if I have something like 2 raised to the power 3 and I'm multiplying with the 2 raised to the power, let's suppose, minus 1. So if this something like this comes to your, see, if I have a values 2 and exponents are different, so I would just write a raised to the power m plus n. I would be just adding or subtracting, like in here it would be just 2, 3 plus minus 1. 3 plus minus 1, you know that is just 3 minus 1, obviously. So it would give you 2 raised to the power what? 2. Okay, so this would be your answer. So fun. So this was my first property. Let us discuss another one. Second of my property is, if I have a raised to the power m, and in place of multiplication I just divide my another exponent having the same base but with different exponent, I would get a raised to the power m minus n. Okay, or I can write this it as m raised to the power m divided by, since the divide sign only signifies that it's lying below the fraction, so it is nothing. I'm just using nothing. I'm just using another convention for writing my division operation. Okay, so I can also rewrite it as this, which I have just used in my above question, where I've just applied my basic laws of exponents, this and this, where I've just, my base was having the same and x was a numerator, whereas y was an exponent of a denominator, so I would have x minus y as my basic laws of exponents. So are you okay with that? Do you able to digest all these things? Okay, so these are my basic laws which you would be remembering. Likewise, if I have 2 raised to the power 1, I have here just 2. So just 2, it is only 1 here, so I would be writing it as 2 raised to the power 1 minus 1, which would give me 2 raised to the power 0, and any raised to the power 0 would, it's 1, which is my another law of exponent, which I'm just about to write. Okay, which I'm just about to write. Let me write it first. I have another laws of exponent, which is my, if I have any a with the base 0, it would give me always 1. So it is a direct 1. You should be remembering, I have 2 raised to the power 0, it will only give me 1. I have 27 raised to the power 0, it will only give me 1. If I have millions, if I have million number raised to the power 0, it would give me 1 only. Okay, so it is your third exponent, third laws of exponent. Clear up till now? You just remember, when multiplication, then you just add up. When in division, you may just subtract, provided base must be in common. Okay, so let us now move towards our fourth one. Fourth property is interesting one. Here, if you have exponent a raised to the power m, okay, and I take n, so it would be just like a m n. Okay, so let me illustrate this as, if I have 3 raised to the power 3, if I treat it as a number and I just take an exponent, another exponent of the given exponent, let me suppose 2, so I would be having like, if you just treat it as a, so you can write it as a raised to the power 2. Okay, so you can just write it as 3 raised to the power, treat it as m, treat it as n, you can write it as 3 into 2, which would give you 3 raised to the power 6. So it is basically, if you have something like this, you just multiply your exponents and you would get your required answer. Fair enough? Okay, so yeah, the next law is similar to the one we have just discussed, the very first in the beginning, but having here my base were in common, here my bases were common and powers were different. Its opposite of it, I would have different bases but power wouldn't be common, let it be m only, and multiplication is happening. So what I would do, I would just multiply my bases, which would be give me AB, and just take a common power, which is my m. Seems clear? Let me just erase this. Are you comfortable with it? So can you just solve a question which would be using the fifth property as I've just mentioned? Can you just solve? Okay, let me assign you then a question. Likewise, see, 2 raised to the power 6 times 3 raised to the power minus 2. Can you just solve? Not minus 2, wait. 3 raised to the power 6 only. So you may just solve, and what you are getting you may just tell. Use the fifth property as I was just discussed above. Yeah, let's check what you are getting. See, I have told you just multiply your bases. Just multiply bases. Bases are 2 and 3 here. So I would be multiplying 2 with 3. I would be getting 6, and just take my common exponent, which is 6. So I would be having 6 raised to the power 6 as the answer. Fair enough? Okay.
Yes, sir. Yes, sir.
My another property states that if I have an exponent in divisions, but with base different, I have a different base, but the power are same. Similar is the case of my second property, wherein the bases were common, but the power were different. We just subtracted the exponents. Here, what would we do? We would just divide whatever my basis is and keep the power as a common one, m only. So if I give you a question like 3 raised to the power 3, and I have to divide it by 2 raised to the power 3, you will be having like, see, just take your bases and divide it. You would be having 3 divided by 2, and just keep the common exponent which you are having, which is here 3. So I would be having 3 by 2 complete bracket with exponent 3, or vice versa is also true. If you are given with this, you may just transpose this to this. Seems clear? Okay, so we have discussed much about the exponents. Let us now move our discussion towards algebraic identities and expressions, which you have learned the basis of which you have learned in your previous classes, previous grades. Let us continue with that. Algebra. So the very first topic which will be encountering is the addition and subtraction of algebraic expressions. Like if I give you an example illustration, like if I have two algebraic expressions, which is my 7x square minus 4x plus 5. This is my quadrant. This is a trinomial. Basically, I would be letting you know within a while the types of my algebraic expressions. For now, let us compare this to be an ideal expression, and I have to add this expression with 9x minus 10. So what you have to notice is you have to just see the common terms. Take the common terms out of this. You have x term here, okay? You have x term, you have x term here, and here you would have a constant which is 5, c. Let me denote constant as c, and here you also have c. Here it is x square term, here you have x square term, and here you haven't. Okay, so what you would be doing is just a basic algorithm you should be remembering. You would write separately using a separate spaces, little bit of spaces in between, and below which you would just place the like term. Like term means if I have a 4x like a term, I would just place a term similar to it. Okay, so I would be having 9x here. Since I am adding, so I would put a plus sign, and I am having minus 10 here, so I would be putting it near my, just below my another constant. Okay, so it would be like if I have x square, below which should be x square term. Okay, if I have x, below which there should be x term only, and if I have constant, below which I must have another constant. So this is a general thumb rule you should be knowing for solving any of the addition or subtraction algebraic properties. So, and below which I cannot put anything, since I'm not having x square term here, so I will be just adding 0 times x square, since 0 times with any term would yield me 0. Okay, we would be treating it as 0 only. So if I just add these two, which is my 7x square plus 0x square is 7x square only, so I would be writing 7x square only. Okay, if I just add this, see I have 9x plus in 9x minus 4x. Since my sign is with a greater term, so I would be having 5x plus 5x. I would solve simply like a normal mathematical operation we would be doing. I would be having 5x, and since minus 10 plus 5 minus 10, here would be 5, minus is with the greater sign, a greater number, so I would be having minus 5. So it would give me minus 5. So this expression which I am getting here is my required addition of the two of the terms which we had been given with. So this is how we find addition. Okay, are you okay with it? Do you have any issues at any of the steps I have just mentioned? You may just pinpoint, or else we should proceed with another question. Okay, seems clear? Okay, so let's just move towards next one. I have to add, it's given, add, we should be solving both this question. You might need a help from me. Okay, if I have a question like this, you may just attempt if you are getting it, or else I am here to assist you. 4yz, wait, let me write it here only, which is 4yz plus 9zx minus 4y. I've taken up the question for letting you brainstorm with me to get your concepts more clear. Okay, so don't fear with the question length. It is nothing, just to make you comfortable with the algorithm. So what was my algorithm? See, I have to just observe my like terms. How much terms? See, I have how much terms are common. See, I have xy like terms. I have yz like terms. I have zx like terms. Except these, see, yz. See, here it's yz. It's already taken up. Okay, so I won't be writing zx. Zx is also here. Zx is here as well as here. Okay, so I won't be considering it. Okay, that's what I have to see first. See, I have y here, but I haven't wrote y, so I would be writing just y. Okay, I have, see, xz, yeah, zx or xz, you just multiply 2 cross 1 or 1 cross 2, they are equal, na? So it's yz or zx are both are equal. Okay, any issues? Are you getting it now? Why we are writing different types of terms here? Because we would be separating the terms, each terms on the basis of there is a like terms and unlike terms only. So that's why I'm separating xz. X, I am not having only alone x, so I would be writing x here. xy I have. So I have these 5 kind of terms in my complete 3 expressions. So what I would be doing is just write separate 7xy, okay, plus 5yz minus 3zx. Okay, I'm having something like this. So let's put, we should only put, see, now let's put 4yz. See, 4yz would come under which of the term? Can you guess? Either it would lie here, or it would lie here, or it would lie here. Can you just guess where it would lie? Let's check it is yz. Where is the yz coming? Yeah, it would lie only below my 5 only, na? What I have learned, the like terms only, like terms. You would always put like terms. If you have constant, so you would put constant, another constant just below the constant. If you have x, you would just put another term with x below it only. If you have x square, you would put x square, another x square term just below for the previous x square term. So if I have 4yz, I would be here writing plus 4yz here only. Since since no sign is given, so I would be treating it only plus. I have 9zx, so 9zx would come under which? Come beneath which term? Either this or this. Can you guess? Yeah, it would lie under minus 3zx. So I would be writing plus 9zx. Seems clear? So I am complete with this and this. Let me introduce minus 4y. So I am not having any y terms here. So can I just write plus 0y? I can also write. So I would be putting my 4y just below my y term. Okay. So this is how my multiplication works. Where if I don't have another similar term, I would create by multiplying it with 0. Since 0 times something would always give me 0 itself. Okay. So seems clear until now? So I am done with my first expression as well as my complete second expression. Let's deal with the third expression and let's quickly add them up. So I have zx term, xz. So xz is where? See, I have zx, xz would only would lie only beneath this like term, which is my zx or xz, both are equal. So I would be putting my minus 3 zx. Okay. xz or zx are both are equal. So I'm sorted with this. Let's place for 5x. Okay, now we don't have a place for x here. So I would create one by multiplying 0 beneath which I don't have another. So I would create 0x. Now I would replace my 5x here. Seems clear? Are you able to figure it out? How are we applying the algorithm? Just the main key idea is to remember like with like. Okay, like term, like with like, unlike with unlike. For unlike you should create another space. For like you should place under the like term which is already given to you. Okay. So let us now place our last term, which is minus 2xy. See, xy we have here. So below which we have 0xy. Okay, since no xy term in my second expression, so I would be having 0xy only. Minus 2xy in my third expression, so I would be putting minus 3xy. Okay, and replacing all the vacant spaces with 0 yz, and here I would be having 0 y. Okay. So I would be having something like this. So if I just quickly add them up, all these, see, xy, let's take it out common, xy. Now let us see only numerals. I have 7, 0, minus 2. If I just add 7, 0 and minus 2, 7 plus 0 plus minus 2, what would I get? I would get what? 5 only. So I would be having 5xy. Seems clear? Here, let us quickly find, we have yz, so I would be having, let me write yz first. I have 5 plus 4 plus 0, so I would be having plus 9yz. Okay, let me deal with zx. I have minus 3 plus 9 minus 3. Minus 3 plus 9, minus 3 plus 9 and minus 3. So I would be having what? Plus 3. So I would get plus 3zx. And let us quickly deal with y, 0y, minus 4y, 0y. So I would be having only this term. So I have minus 4y. Okay. Here I have 0x, 0x and 5x. So I would be having just plus 5x. So finally I would get this, the blue wrote stuff is my required answer. Are you okay with that? Are you able to digest the complete algorithm? I have deliberately given you the lengthier question of my exercise with me, So to let you completely understand the concept. Okay, so let us now move towards, if you are okay with that, if you have any issues, you may just pinpoint at any point of time. The screen is in front of you. You may just see if you have any issues at any point of time. Okay, you may just see. Let me find out another in the set of topics under the discussion. Yeah, next it's my multiplication of algebra. Multiplication with monomial. Now let us see. Okay, you are clear with it? Okay. See, if I have something like 7x, okay, and I write minus 2x, what would you do? Just subtract having 5x. Seems clear? Okay, and if I have what? If I have something like 7x plus 2xy, what would you do? Can you do something here? You can't do. So you would be just letting it what it is be, what it is. So you would just leave up to here. So you wouldn't be doing anything. So anything which has two terms, any algebraic expression having what? Two terms, it would be calling it as binomial. Bi means two. And if you have just only a single expression, you would be naming it as just one expression. Okay, you would be naming it as what? Mono. Mono means one. Monomial. Okay, mono means one. And if you have something like 5x plus 3y plus 8yz, something like this, if you have this, which you can't add any of these, since all are unlike in nature, so you would be having three terms for your algebraic expression. This is complete your algebraic expression in where you have three terms. So 3 means trinomial. Seems clear? Seems clear now? So these are my general conditions, basic classification of my few of the polynomial. Since polynomial, poly means many, polynomial, you may just classify any greater of these monomial, like the trinomial, trinomial, or having the 4 terms, 5 terms, unlike terms, you may call a polynomial as a general term. Poly means many, more than one. So it is basically a polynomial classification. Let us now discuss. You have understood monomial, binomial, and trinomial. So let us now discussing multiplication. Multiply monomial with monomial. Seems clear? Let us discuss monomial with monomial. By monomial with monomial, I am assuming 2x as one monomial. I am multiplying it with, let us suppose, 3y. Okay. So what I would be doing? Just multiply your numbers. Just multiply your numeral with numeral, which would be 2 cross 3 here, and just multiply your remaining variables as it is, x cross y. So you would be having something like 2 cross 3 being 6. X cross y is only xy. So 6xy would be getting your answer. So it is just the direct monomial with monomial multiplication. Let me give you another illustration. Let us suppose multiplying 7xy, it is x, okay, 7xy multiplying with minus 3x, okay. So these both are individual monomials. So if I multiply these, just multiply numerals, which is here 7 and minus 3, 7 cross minus 3, okay, cross. Now multiply all of the individual variables, which is your x, y, cross y. So 7 cross minus 3, Can you just guess? Can you just pop your answer? Yeah, it's minus times 21. Okay, cross C. Here you would be applying what? Here you would be applying your laws of exponents, which I've just mentioned about the concept. See, if I have nothing written here, it would be 1 only. I have nothing, 1 only. If I have base common base, if I have a base common with different or same exponent, I would be having what? A x plus y. So I would be just adding my both the exponents. So I would have x1 plus 1. So I would be having x square y since y is only 1. So I can write it as minus 21 x square y. So this would be my answer for the given question. Okay, are you okay with it? Any issues at any point? Clear? Okay, so let me give you few of the one of the question for solving by yourself. Can you just solve? Can you just solve? Okay, okay, yeah. What I've discussed with you, just multiply your numerals with numerals. You would be having minus 8 into 3. Okay, multiply the rest of the variable given as it is. You're having something like this. This step is clear? So minus 3 times 3 is what? Minus 8 times 3 is what? Yeah, minus 24. Okay. So I have an exponent 1. I have bases in common x and x. So x 3 plus 1 3 plus 1. So I will be having x raised to the power 4 times y. This step is clear. And the step would be minus 24. I would be just multiplying the numeral with my variable. So this would be my answer, final answer. Okay, seems clear? You won't be leaving up till here. You would be writing up till here only for getting full marks. Okay. So this was our case for multiplying monomial with monomial. Okay, so let us now see our case with our discussion with multiplication. Multiply monomial by binomial. Okay, let me illustrate the concept. Let us suppose I have a monomial like just 3x. I have to multiply it with 2x minus 2. Okay, it is a binomial since I have two terms which cannot be solved further. So I would have a set of what? Binomial and a monomial. I'm in multiplication. So what would I do? So see, for multiplying such cases, let me introduce a concept which is my distributive law in algebra, which is very famous in algebraic dimension of mathematics, which states that distributive. See, I have to distribute my multiplication over different terms. If I'm multiplying 3x with this complete binomial, I would just multiplying 3x with 2x first, put negative sign, then multiply again 3x with the remaining exponent, with remaining term you have. So here it would give me what? Can you just guess? 3x. I have told you just multiply with 2x alone, put your next sign which is given to you, again multiply 3x with another term which is 2 here. So you would be getting this. Now your expression becomes what? Now your expression has become monomial cross monomial. Seems clear? These are just monomial 2x and 3x, and here only also monomial cross monomial. So this is like you used distributive law to break monomial cross binomial to monomial cross monomial terms. So, and monomial cross monomial you are very comfortable with. You have just solved few of the illustrations. So you would be just multiplying. You would be just multiplying your numbers with numbers and variables with variables. So let me write 6 x with x is raised to power 1 is 1, so I would be just having x 1 plus 1, okay, minus 3x with 2x I would be having 6x only, okay. So let me, it would be 6x square minus 6. Are you comfortable with it? Are you able to seems interesting or not? Yeah. So this is how we just use our distributive law for the determination of multiplication of a monomial with the binomial. Okay, let us solve another question together. Okay, wait. Let me find a question. Yeah, I've found a beautiful one. Let us solve it together. I have to multiply a square in multiplication with 2ab minus 5c. Now determine, this is my what? Monomial. This is my what? Binomial. Okay. So if I have to just multiply, use your distributive property. Okay, what you would be distributing is just multiply a square with 2ab. So I would be having a square multiplied with 2ab, put the sign as it is, minus multiply a square with 5c. So I would be having a square times 5c. Okay, so now your expression converted into monomial cross monomial. So here you are easily familiar with. What you will do is, you may just see, I have a here as well, a with the exponent 1, a with exponent 2. Applying your basic laws of exponents, you would be solving it question like 2a cube b minus, I have no like terms here, so I would be writing 5a square c as it is. This would be my answer for the question. Seems clear? Are you okay with it? Let me assign a question, another question, interesting one. Just solve. Let me know at each step what should I write. First of all, what should I determine? Which is my monomial and which is my binomial? Yeah, this is my monomial, this is my binomial. Okay. What I would do next? What I would be using? Another property? Any property? Yeah, distributive property. So I would be applying my distributive property, like I will be multiplying 2x with 3x first, putting plus sign, multiplying 2x with this. So I would be having 2x in multiplication with 3x. This thing only, na? Or here, what would be writing? You should tell me what I would be writing. What should I be writing here? I'm just multiplying. See, I was just multiplying 2x with 3x. Just put my negative plus positive sign here, and I will multiplying 2x with what? 5xy. So what would I write here? Yeah, I would be writing 2x in multiplication what? 5xy. Yeah, that's great. So now I've converted monomial cross monomial. So herein I would be having 6. I have x raised to the power 1 and 1, so I would be having x raised to the power 1 plus 1 using my basic laws of exponent property. Here also I have exponent 1 and 1. Can you just tell me what I would be writing here? Yeah, 2 cross, just multiply numbers first. 2 cross 5 is my 10. X cross x would give me x raised to the power 1 plus 1, like here it's given, and y is alone, so I would be writing y as it is. So here I would be getting 6x square plus 10, what I would be getting here? Yeah, x square y. So this would be my final answer. So I hope so you are also comfortable with monomial and binomial multiplication. Okay, I would be assigning few of the questions as your homework, but till now let us now move our final discussion with multiplication of a monomial with our trinomials. Okay, shall we discuss? If you haven't any issues up till here, may just pop up at any point. I may just illustrate it once again what we are having doubts with. So if you are familiar with enough of these, let us now quickly see multiplication of a monomial with the trinomial. Okay, if I just use my basic multiplication of monomial into trinomial, m cross t. Okay, let me illustrate using a direct one, which I've been having with me. I have a polynomial 3p. P is my variable here, like x, y, z only. I have another, this one being my monomial. Okay, here I have 4p square plus of 5p plus 7. See, I have here one term, so I would be treating it as a monomial, and here I have what? 3 terms, so I would be having a trinomial. Clear enough? Yeah, so this is my monomial, it's my trinomial. Let me remove those. Okay, if I just multiply, again here, what I would be using, can you guess? Can you guess? Yeah, I would be using only distributive law, direct distributive law, which is stating just multiply each term, put the sign as it is, again multiply each term, put the sign as it is. I am putting my positive sign because it's positive. If it was negative here, you would be putting the same sign as it is. Okay, and multiply here again. So here I would be multiplying 3p with 4p square, 3p with 4p square. Seems clear enough? Fair enough? Multiplying 3p with another 5p, 3p with 5p. And can you tell me the next? Yeah, 3p times 7. So this thing I would get. So let me just quickly sum it up. I would be having 12 p raised to power 1 p into p square would give me what? P 1 plus 2. Okay, using the basic laws of exponent. 3 cross 5 would be 15, power are 1, so it would be p raised to power 1 plus 1. Positive sign, numerical 21, p only. On further simplification, I would get 12p cube plus 15p square plus 21p. Fair enough? So this is my final answer. Let me highlight. Okay, so in this session I have already discussed about exponents and basic operations on my algebraic expression. In the last class we would see further of the question practice. For now I have been assigning few of the questions. You should be doing it by yourself at your home, until which let's close the class. Okay.